James Webb Space Telescope is a reflecting telescope, which means it images the universe with the help of mirrors. We are here at L3 IOS Tinsley in Richmond, California, to find out just how the observatory will work.
So I'd like to first show you one of our primary mirror segments, and before we get too close, we'll want to put our mask on to protect the optical surface.
Okay.
This is one of our 18 primary mirror segments. Once they're all complete, they'll combine to make one large primary mirror. You can see the front side surface is highly polished, and as we rotate to the back side surface, you'll see that there is a honeycomb light weighting, so it reduces the payload when it goes up into space, and yet it's very stiff.
It looks like you can attach things to it too.
Yes, they bond more hardware on the backside surface, which makes it an even stronger structure, and that's the way it'll go up into space. There are several other mirrors that we're doing here for James Webb Space Telescope. We have a secondary mirror element, we have a tertiary mirror element, and we're also doing the fine steering mirror.
Now, for those of us who don't understand how a telescope works, why do you have so many mirrors?
The light that comes from space is collected into the primary mirrors. Primary mirrors then take that light and image and bring it to the secondary mirror, which projects it to the tertiary mirror, and then that goes to the fine steering mirror, and then with fine steering mirror they're able to adjust it and move it around and get the images that they're looking for.
Why all the bouncing around?
Well, the mirrors work together to reduce the aperture size to a format that can fit on a camera that we can image. Now that we've seen the primary mirror, I'd love to show you the secondary mirror.
So Andrea, what's going on here?
We are performing a microscope inspection of the surface. What he's doing here is he's getting very close to the optical surface so that he can capture surface data, and then we can look at that later on. And you can see this one is unique compared to the other mirrors. This one is a convex hyperbola, whereas the primary mirror and the tertiary mirror are all concave.
And there's only one of these?
There's only one of these.
So on the telescope, the light captured from the primary bounces onto this next, right?
Yep, that's why they call it the secondary element.
2 switches, I can pick 2.
We also have the tertiary mirror, which is a concave ellipse. This is a onesie mirror, just like the secondary and the fine steering mirror. It's a one of a kind in the telescope. And with this mirror, we run through the same sort of rigorous testing that we do for the primary and the secondary mirror. And we get down to those tight specifications that are required to maximize the image resolution.
Thanks a lot for your time, Andrea, and showing us your mirrors.
Welcome.
Andrea showed us a segment of the primary mirror, the secondary mirror, and the tertiary mirror. She wasn't able to show us the fine steering mirror. That's the mirror that keeps the beam of light collected by the telescope centered and stabilized. That's because that fine steering mirror is inside this thermal chamber, going through some extreme temperature changes to simulate the conditions of space. Thanks for joining us for another edition of Behind the Web.